Okay, so how do you create a limits of agreement graph? Well, let's start off with our Excel spreadsheet. So let's zoom in on what we've got here with our data sets. Here we've got a data set. We've got repeat conditions. So it doesn't matter what the conditions are. We've got 2 repeat conditions. We've got 0 degrees in trial 1. So this is maybe an elbow being held at 0 degrees. This is maybe doing grip strength. And then we've got it trial 2. And so with limits of agreement, we're trying to find out whether there is reliability across these 2 conditions. So the first thing we have to do with limits of agreement is we've got to follow the basic instructions. We've got to calculate what is called the bias score, and we've got to calculate the 95% confidence intervals. And coupled with that, we've got to know where the population sits within that data set. So the first thing you've got to do is you've actually got to work out what the mean is for each participant. So what was their mean score across each of these? And this is going to be fundamental, because one of the things we're going to plot is we're going to plot the mean on a limits of agreement plot. The Bland Altman plot is the mean versus the difference. So we'll work out the mean. So we're going to put the mean in here, and a number of different ways in which you can do this, but here's a quite simple way. Just if you're not sure how to type in the kind of the function, go to formula, insert function, average, hit OK. Click on this checkbox here, so you'll notice now that it's highlighting my box here, and this dialog comes up. Just highlight the 2 cells that you want to work with. You'll notice now it says A2, B2. Close the checkbox, and now it's created the average of those 2. And if you want to just get all of them, double click when you see the arrow changes, double click, and it's now referred to all of those as the average. So the next thing we want to calculate is we need to know what the difference is. So we'll label that column the difference like this. And the difference, it doesn't really matter which way around you do this. It's not really a massive importance. But in the purpose of this, I think we'll take the difference between the second and the first. So we're going to drop in the formula. So equals, in this case, B2, you can see it's been highlighted, minus A2. And you can see A2 has now been highlighted. We're going to click the tick mark there, and it's done that for us. And now what we're going to do is double click, and it's created the difference across all of those columns for us. Don't forget, when you're doing these kind of calculations, you may want to add in at the bottom here the mean for each trial as well, because that would be important in your overall data set that you're going to compile. So now you've got the mean and you've got the difference. So how do we now get what are referred to as our 95% confidence intervals and the bias score? So how do we actually get to those? So what we need to do now is get to the bias. Well, to get the bias is the mean of the differences. So let's plot in or drop in our mean of the differences down here. Same function, insert average. Slightly different in the sense of what we're going to do is we're going to take the whole column, so we'll just highlight the whole column we want to work with. So you can see it's all highlighted, not covering over the one that's the actual cell we want to work with. And so now we've got the mean of the differences. Now the next thing you want is you want to know what are called the 95% confidence limits. And these are the upper and lower limits that go onto the limits of agreement graph. They show in essence where the data is spread. To work those out, it is quite simply the bias score that we have here. So now we need 95% confidence intervals. How do we get to these? Well, first thing you need to work out is you need to know the standard deviation for the differences. So again, we'll insert the function. This time though, we're going to go to stdev, that's standard deviation. Highlight the data set that you want, like this. Exactly the same principle as we've just done with the average. Drop that in, and there we go. So you've now got the standard deviation for the differences that you can see there. Okay, so this gives us the standard deviation. Now we need to get the 95% confidence interval. So let's just make sure that we don't lose track of what's going on. That's the mean. That's the standard deviation. Now we're going to get our 95% CIs. And the way you do this is you take the standard deviation and you multiply that by 1.96. So we're going to take the value, which is D45. So remember, we've got to put the equals in. So D45, and we're going to multiply that by 1.96. So that gives us a fixed value here. So this is the value. So all we're going to do now is we're going to create the upper and lower scores. And to create the upper and lower scores, we are going to add the confidence interval to get the upper value to this mean of the differences. And to get the lower value, we're going to take this value away from the mean of the differences. So if we write in here upper and lower, okay, so let's work out our upper limit. So we know that the bias score is equals D44. We want to add on our confidence interval, so that's D46. So D46. So that gives us our upper confidence limit. So now for the lower one, it's the same principle but in reverse, equals D44 minus D46. And that gives us our lower limit. So we've gone up and down based upon the 95% confidence intervals. So once you've got that data, you are then going to plot the graph which corresponds with that data. So very briefly, I'll show you how this works. It's very, very simple to do. Let's zoom out a little bit so we can create some space. And the columns you're going to plot, plot the mean versus the differences. So you just take those two columns there, you insert your recommended chart, and there it is. It's already come up with it. It is an XY scatter that you want to plot. You hit OK. I'm going to zoom out again so we can see the whole graph. Let's bring him into play here so he's kind of visible. Get rid of some of these things here. We don't want that on there. Now you can see that what you've got is you've got the whole plot area. Now go and watch other videos on how to format graphs appropriately, but let's just get rid of the grid lines to make life easier for us to kind of follow what's going on. So now what we need to do is we need to add on the bias score and the 95% confidence interval scores. So if you remember, our bias score, which is here, is minus 1.607. Now remember that the graphs that we're creating here when we are doing these graphically are only just a pictorial representation. It's the data itself which really gives us the key information. So to do this, it is quite simple. Just insert, go into illustrations, select a shape. You want to use the line function. And we know it's 1.6, so we're going to drop him in at around about here. It's, again, as I say, these are only meant to be kind of a rough indication of what's going on. So we've got that in. So now we've got our bias score, but now we need to go up and down. So the upper is 4.85. So quite quickly, if we just edit, and we're going to copy that line, and we know it's 4.5. I'm going to drop the line in here. I'm going to drag him up. So 4.5, it's about there. I'm going to differentiate this line just so that we can see it. So I'm just very quickly going to format the object so that we can just separate these two out. So let's put this in with a dash type like that. And then if I then go down, so I'm going to copy again, and this time we've got to go to -8. So -8. So let's drop him in and let's just check that. So it's negative, yeah, it's pretty much -8. So we go down to -8, which is here, and there you go. So now what you've got on your graph is you've got the bias score, which is the blue line, which is sitting in the middle, and then you've got your upper and lower 95% confidence intervals. And you would label these axes, so you would label these axes to represent, in essence, this is the mean value here, this is the differences on here, and this is then the graphical, it's what's called a Bland Altman plot, which represents what you have got here in terms of the data. But remember, this is just a graphical representation to make it easier to understand what you're using or doing with the data.